I'm sitting here today with Hans Peter, and Hans, we've worked closely together in the last few months working on Kafka connector and MongoDB. I know you wrote an initial connector, and we've now taken that over, maintenance for that. So we're just here today to talk a little bit about Kafka and MongoDB and kind of what some of your thoughts are for the future going forward.
Yeah, happy. Look forward to our discussion today.
So I know you gave a talk today. Could you tell us a little bit about the use cases you discussed and kind of what you presented?
Yeah, sure. So the idea of today's talk was to show people that other than only using Kafka to integrate services on an application layer, we can also use it to do that integration further down by one level, namely at the persistence layer. And it was the idea to show people how easy it can be to leverage Kafka Connect and integrate like any data sources with any data sinks which are spread across your landscape and which are originally disparate systems.
Mm-hmm. And it was you were speaking about ETL specifically. Like where do you see? I mean, ETL is a very complex problem. So where do you see Kafka fitting in, and what do you really see it solving there?
Yeah. So actually, I think it depends first and foremost how you would define ETL. So like we all know what it basically means. Like we want to take data out of some data source, like the extraction part. Then most of the time we need to do some kind of computation or transformation on top of that data, and then the load part is to put that somewhere else. And exactly this pattern is what was originally done in a very batch-oriented way. And the idea to use Kafka as an event streaming platform there is to make sure that you can have a very low end-to-end latency when it comes to reacting to changes that are happening in the data source and feeding them into the sink. Now, Kafka Connect has plenty of advantages to offer in the sense that you do not have to write any boilerplate integration code on your own. Like no plumbing is what you would need. Like all you do is go for ready-made connectors, configure them properly, and start streaming data in either direction. Another nice property is that Kafka there is the decoupling component, meaning that your source can happily act and feed data into Kafka without noticing, for example, that maybe you have a short downtime at one of your data sinks. So this is another great advantage, like Kafka being the buffer in between, if you want. And then you can do this transformation part, and there you have also not only the option to simple transformations on single messages. That can be configured as well on Kafka Connect level, but you can employ a fully fledged stream processing application that does plenty of more things, like enriching a stream of data with another stream of data, or enriching a stream of data with rather static reference data that you want to join with. And you can do even things like pre-computations and aggregations on the fly, so that you can keep your sink from being overloaded and doing lots of unneeded computations.
So as you look ahead the next couple of years with Kafka, MongoDB, like where are some areas do you think MongoDB could add value in the current, what can we do with the current connector to continue to add value to the data processing stream there?
Yeah, so I think we have to differentiate here as well between source and sink. And actually in my talk today, I just brought up 2 or 3 sample scenarios where it would make a lot of sense to combine Kafka with MongoDB. And one was about building a single customer view. Like you have plenty of different sources, heterogeneous systems, and this would basically mean that if you try to go the direct route, you would need to write a lot of custom code, like to feed data from 10 different databases into Mongo. And this is a very, very good reason to leverage source connectors that are already there for the other systems, bring the data to Kafka, and then just configure the sink accordingly to build something like a customer 360. That is one very viable use case that people have already done, I'm sure. Another one is like synchronizing data across service boundaries, like microservice architectures, where we often have the need to communicate anytime something changes in service A, we need to communicate that to service B. And also there you could go on a very small scale and a very simple setup, you could go for custom code, like informing the other service by means of synchronous HTTP call. Now this works fine, but as soon as you need something more scalable, more resilient, it would mean a lot of work. And here again, it can make a lot of sense to let services write to Kafka first, and then use sync connectors here again to spread and actually route the data accordingly, so that all the services can basically use Kafka as the decoupling component to inform about data changes in a reliable way.
Well, Hans-Peter, thanks so much for chatting with us today. Thanks for traveling to London to speak at our event. We really appreciate it. Thanks.
Yeah, it was glad to be here. Thanks for having me.